percentage composition, and molecular formula. Number of researchers and scientists in the field of chemistry are constantly synthesizing new compounds. After synthesis of the compounds, the characterization and determination of chemical formula is essential. This can be done by sophisticated, modern techniques, like microwave, infrared, ultraviolet, electronic, Raman spectroscopies, and nuclear magnetic resonance. Simpler methods consists of analysis of the compound, which leads to determination of amounts of the constituent elements in the compound. Consider a molecule of ethanol, C2H5OH with molecular mass 46. Each mole of ethanol contains 2 moles of carbon atom. Equals 12 into 2 equals 24 grams. 1 mole of oxygen atom equals 16 into 1 equals 16 grams. 6 moles of hydrogen atom equals 1 into 6 equals 6 grams. These amounts of carbon, oxygen, and hydrogen are present in 46 grams of ethanol. Hence the percentages of constituent elements are percentage of carbon equals 24 upon 46 into 100 equals 52.17%. Percentage of oxygen equals 16 upon 46 into 100 equals 34.78%. Percentage of hydrogen equals 6 upon 46 into 100 equals 13.05%. Therefore, each 100 grams sample of ethanol contains 52.17 grams carbon, 34.78 grams oxygen, and 13.05 grams hydrogen. From any unknown sample of a compound, percentage composition can be determined experimentally. For example, in case of ethanol, known mass of pure sample can be burnt completely in air. The reactions is C2H5OH plus 3O2 gives to 2CO2 plus 3H2O. The experiment may be devised where the products of the combustion reaction may be absorbed selectively in suitable reagent and then analyzed. Hence, the masses of carbon dioxide and water can be determined, from which percentage of carbon and hydrogen could be determined as the sum of the percentages of the constituent elements is 100. The difference between 100 and sum of the percentages of carbon and hydrogen is the percentage of oxygen. Now suppose that the result of an experiment indicates that 100 grams sample of ethanol contain 52.17% carbon, 34.78% oxygen, and 13.05% hydrogen. Hence the number of moles of each component atom per 100 grams ethanol can be calculated. Number of moles of carbon equals 52.17 upon 12 equals 4.3475. Number of moles of oxygen equals 34.78 upon 16 equals 2.1735. Number of moles of hydrogen equals 13.05, upon 1 equals 13.05. Hence, the ratio of number of moles of oxygen to carbon to hydrogen equals 2.1735, is to 4.3475, is to 13.05, equals 1, is to. Steps for determination of empirical and molecular formula of a compound. 1. Percentages of all the elements present in the compounds are determined experimentally. The sum of the percentages of the constituent elements must be 100. If it is less than 100%, then oxygen is present, with percentage equal to difference between 100 and sum of the percentages of the constituent elements. 2. The number of moles of each constituent element present in 100 grams of the substance is obtained by dividing percentage of the element by its atomic mass. 3. The ratio of number of moles of constituent elements is determined, and the ratio is converted into smallest simple whole number ratio. For example, in case of C2H5OH, the smallest simple whole number ratio, in the order of carbon, is to hydrogen, is to oxygen, is 2:6 is to 1. 4. If the ratio obtained is fractional, then it may be multiplied by convenient integer to obtain whole number ratio. Sometimes minor fractions are neglected, and the ratio is converted into simple whole number ratio. 5. The whole numbers of the ratio of number of moles of elements are written as the subscripts to the right side of the corresponding atoms of the elements to obtain empirical formula of the compound. 6. Molecular mass of the substance is determined by convenient experimental method. Then the ratio of molar mass of the substance to the empirical formula mass of the substance is determined, say it is R. Then molecular formula equals R into empirical formula of compound. Calculate the mass percentage of different constituent elements in urea. Solution. Molecular formula of urea is CONH2, 2. Hence, its molar mass is 12 plus 16 plus 14 plus 2 into 2 equals 60 grams per moles. Percent of carbon equals 12 upon 60 into 100 equals 20%. Percent of oxygen equals 16 upon 60 into 100 equals 26.67%. Percent of nitrogen equals 28 upon 60 into 100 equals 46.67%. Percent of hydrogen equals 4 upon 60 into 100 equals 6.67%. Hence, the mass percentages of urea are 20% carbon, 26.67% oxygen, 46.67% nitrogen, and 6.667% hydrogen. A compound with molar mass 159 was found to contain 39.62% copper and 20.13% sulfur. Suggest molecular formula for the compound. Cu equals 63, S equals 32, and O equals 16. Solution. Percent copper plus percent sulfur equals 39.62 plus 20.13 equals 59.75. This is less than 100%. Hence, compound contains adequate oxygen, so that the total percentage of elements is 100%. Hence, percent of oxygen equals 100 minus 59.75 equals 40.25%. Moles of Cu equals percent of Cu upon atomic mass of Cu equals 39.62 upon 63 equals 0.629. Moles of S equals percent of sulfur upon atomic mass of S equals 20.13 upon 32 equals 0.629. Moles of O equals percent of oxygen upon atomic mass of O equals 40.25 upon 16 equals 2.516. Hence, the ratio of number of moles of Cu is to S to O is 0.629 upon 0.629 equals 1. 0.629 upon 0.629 equals 1. And 2.516 upon 0.629 equals 4. Hence, empirical formula is CuSO4. Empirical molecular mass equals 63 plus 32 plus 16 into 4 equals 159. Molecular mass equals empirical mass. Therefore, molecular formula equals empirical formula.